Hi everyone, welcome to Elecom Edu. So this is the fourth session. So till earlier session, you studied all the basics of electronics, like what is a semiconductor, what are the types of semiconductor, how to fabricate those semiconductors, orbit and other things and all. So before going to watch this video, kindly watch the earlier videos, right? Okay. So now I am going to teach you about the electron devices. So if we want to design any electronic circuits, so we need the electron devices. So we need some electronic devices. By that electronic devices, you can able to design a electronic circuits. So once you consider the electronic devices, so those electronic devices are broadly classified into two types. One is a active devices and another one which is a passive devices. By using this active devices and passive devices, you can able to design a complete electronic circuits. So from this word itself, you can understand what may be active device and what may be passive device. So active device in the sense that device which provides the action or activity on the particular circuit. So if it is a passive devices, the devices will be available but it can't able to activate the circuit, right? Okay. So active devices, one thing you should remember, it is a source. So active device in the sense it is a source. If it is a passive device, there won't be any source. But if you want to design any electronic circuit, you are in need of active device as well as passive device. Okay. So passive device, there are three discrete components in the passive device. So one component which is termed as a resistor R, another one component, second component which is a inductance L, and another one component which is a capacitor C. So passive device, it don't have any source. So no source, I mean source is absent, but even it should be available in the circuit. It won't do any action of the particular output. So there are three components. The components are resistor, inductor as well as the capacitor. Next is the active component. Active component in the sense it is a source. So this active component, I will take a basic example, diode and transistor. One is a diode and another one it is a transistor. This transistor can classified as two types. One is a BJT and another one which is a UJT. Anyhow, we will study all these things in the forthcoming session, but just I am introducing you. So active devices in the sense source, it acts as a source. It is a very active component in the particular circuit. The examples are diode as well as the transistor. It is of two types as BJT and UJT. So what is this BJT? B represents bipolar, J represents junction and T represents transistor. It is a bipolar junction transistor. So another one which is a UJT. So U represents the unipolar. As usual, J represents the junction and T represents the transistor. Right? So by this class, we are going to study about these passive devices as well as one component diode. Okay. So passive devices. So passive devices, first is a resistor, second is an inductor, third is a capacitor. Resistor. The resistor should be represented by the letter R and the unit of resistance is ohm, and this is a symbolic representation. So this is the first passive components, resistor R, The unit is ohm. This is a symbol for ohm, right? So resistor, this is a symbol for resistor, right? This is a symbol for resistor. So resistor which resists the flow of current. So last class itself I told what is current. So current is a flow of charge carrier. There are two charge carriers. One is a electron E minus and another one it is a holes E plus. Okay. So one is a electron. So the flow of charge carrier electron which is termed as a current, the flow of charge carrier holes which is called as a conventional current, right? So resistance which actually resist the flow of current, I mean it acts as a obstacle for the flow of current. Next is a inductor. So inductor, it should be represented by the letter L, right? So the unit of the inductor is Henry. So Henry is a unit for the inductor. So the inductor will be like this. So this is actually the inductor. This is a symbol for inductor. Okay. So the last one is a capacitor. So capacitor should be represented by the letter C. The unit of the capacitor is farad. The unit of the capacitor is farad. So it will be available like this, right? So it is a two parallel plate. So capacitor is nothing, it is a two parallel plate. So already I said resistor, it resists the flow of current. These inductor and capacitor which acts as a storage devices, which we used to call it as a storage devices. So something is stored there. The inductor which stores everything as a magnetic field, the capacitor which stores everything as a electric field. Okay. So the inductor which is a magnetic field and the capacitor which is the electric field. So these are the three passive components, right? Okay. So next, I hope you remember, next is an active component. Next component is an active component. So that is the active devices. So what is the first active device I mentioned? It is a diode. The first active device is a diode. Okay. See, so from this itself, you can separate this as a two word. One is a die and another one it is a electrorod. So diode. So diode is a dielectrorod. Okay. So there are two electrorod. So one electrorod is a anode and another one electrorod is a cathode. So there are two electrorod as anode which is a positive, cathode which is a negative. So if these two electrorods are combined together, we used to call it as a diode, which is a very basic component of all the electronic devices. So if you want to design or fabricate any electronic devices, the basic component needed which is a diode. It is a combination of two electrorods, right? Okay. For this diode, you have a particular symbol. So this is a symbol for diode, right? So it is having two electrorod. See, this electrorod which is the anode, already I said it is a positive representation. This electrorod which is a cathode which is a negative representation. This is a symbol for diode, right? So one is the anode and another one it is a cathode. Okay. So this diode we used to call it as a semiconductor diode. This diode we can call it as a semiconductor diode. Otherwise we can call it as a PN junction diode. Right? Semiconductor diode. So what is a semiconductor? The material which can able to conduct partially. So last class we studied two types of semiconductor. One is a p-type semiconductor and another one which is a n-type semiconductor. So that's why this diode is termed as p-n junction diode. P-type semiconductor, n-type semiconductor junction. So junction means it is a place where two semiconductors meets each other. That is a junction. See here, this is a block diagram of semiconductor diode. So this is a p-type semiconductor and this is a n-type semiconductor. So this is one material p-type, right? This is one more material n-type. This p-type material which meets with the n-type material. So this place is termed as a junction. So this is p-n junction diode. Why we called it as a diode? It is having two electrorods. So one metal I am taking from p side and one more metal I am taking from the n side. So which metal I am taking from the p side, which is a positive representation anode, which a metal I am taking from the n side, which is a cathode, right? So p-n junction diode, cathode as well as the anode, okay? Right. So last class we studied about the p-type semiconductor as well as n-type semiconductor, okay? What is a p-type semiconductor? Where majority charge carriers are holes and minority charge carriers are electrons. In the n-type semiconductor, the majority charge carriers are electrons and the minority charge carriers are holes, right? Okay. So how we fabricated this p-type semiconductor? By using a trivalent impurity. So how we designed n-type semiconductor? By using a pentavalent impurity. So either silicon or germanium should be doped with the trivalent impurity. It will become a p-type semiconductor. The same silicon or germanium doped with the pentavalent impurity, which is a n-type semiconductor. Okay, right. So the trivalent impurity, which is called as a acceptor, the pentavalent, which we used to call it as a donor. So this is a acceptor impurity and this is a donor impurity. Okay, right? Right. Okay. See, now check this blocks, right? Basic block. So p-type semiconductor. In p-type semiconductor, which are the majority charge carrier? Holes are the majority charge carrier. So holes I am representing it as E plus and the electrons I am representing it as a E minus. Okay. So for the convenient, I am just drawing this as a big block, right? So this is my junction, this is my p-type semiconductor and this is my n-type semiconductor. Here electrons are the majority charge carriers. So E plus, E plus, E plus, E plus, E plus. See here, electrons are the minority charge carriers. Right? So E minus. So electrons are the minority charge carrier. In the n-type semiconductor, where electrons are the majority charge carriers, see here, electrons are the majority charge carriers and holes are the minority charge carriers. Okay, right? Here what will be available? Acceptor impurity will be available. So what is that acceptor impurity? What is the acceptor? Holes are the acceptor. But this acceptor impurities are ions. So what is those acceptor impurity? The acceptor impurities are the ions. So here acceptor impurity is available. Here donor impurity is available. So acceptor impurity in the sense, just to make it as plus. Okay. Here it is a donor impurity. So means that those are the ions. So this is the actual structure of the PN. Okay. Right. So I hope till this everything is clear for you, right? So in the P type, where holes are the majority charge carrier and electrons are the minority charge carrier, as well as acceptor impurities are available. In the N-type semiconductor, where electrons are the majority charge carrier, holes are the minority charge carrier, and donor impurities are available. Okay. So here I want to introduce three particular words for you, right? So these words may helpful for you to understand the forthcoming classes, as well as this will helpful for you to write another examinations like GATE or government exams, something like that. Okay. See, there are two types of current. One is a drift current and another one it is a diffusion current. So these two words you should know, as well as you should understand what is this drift current as well as diffusion current. So another one I want to introduce is a depletion region. The depletion region, we can call it as a space charge region also, right? So here there is one more potential that is called as a barrier potential. So these are the four words you should know while studying about this diodes. So there are two different current, drift current as well as diffusion current, and one particular region called it as a depletion region, otherwise a space charge region. Next you should know this barrier potential. Okay, right, right. So we will see what is this drift current, diffusion current and all, right? Already you know, in the p-type semiconductor, where holes are the majority charge carrier and electrons are the minority charge carrier. In n-type semiconductor, where electrons are the majority charge carrier and holes are the minority charge carrier. Already you know current. What is a current? Moment of charge carrier, right? If the charge carrier is moving from one place towards another place, we used to call it as a current. Okay. See here, diffusion current. So diffusion current, which is happening because of the majority charge carriers. So this has happened because of the majority charge carriers. So if it is a drift current, that has happened due to the movement of the minority charge carriers. This has happened due to the movement of the minority charge carrier. See here, which are the majority charge carrier? Holes. Here, which are the majority charge carrier? Electrons. If the majority charge carrier electron, which is moving from N region towards P region, as well as the holes, which are the majority charge carriers moving from P region to N region. So that current is termed as a diffusion current. See, holes which are moving from P region to N region, as well as electrons which are moving from N region to P region. This is actually termed as a diffusion current. Clear? Okay. Next is a drift current. So what is a drift current? Minority charge carrier. See here, which is the minority charge in your n-type? Holes are the minority carriers. Here, which is a minority carrier? Electrons are the minority carrier. If the electrons are moving from p-type to n-type, holes are moving from n-type to p-type. So this is actually termed as a drift current. If the drift current should happen, means that it should have some electrical potential. So because of the electrical potential, this current is producing. But for the drift current, no need of any electric field. Simply the current will go on. That is the diffusion current. Okay. So next is a depletion region, otherwise a space charge region. Depletion, so means that is a region where depleted charge carriers available. Otherwise, depleted ions will be available. So that's why that particular region is termed as a depletion region. Space charge region. It is a space region where some immovable ion or charges are available. That's why we used to call it as a space charge region. Okay. Barrier potential. So potential you already know. So what is mean by potential? Voltage. Voltage is termed as a potential. Okay. So barrier potential. So barrier means it is a stoppage. So that potential is a stoppage potential. So that's why we used to call that potential as a barrier potential. Okay. So now clear what is a diffusion current, drift current, depletion region and barrier potential. Now we will see one by one. Okay. So first we will see what is a diffusion current. Okay. So what is a diffusion current? Majority charge carriers are moving. That is termed as a diffusion current. Again, come to this part. In P region, where holes are the majority charge carrier, in N region, where holes are the minority charge carrier. I mean, the concentration gradient of holes is more in P region when compared with the N region. Okay, come to the N region. In N region, where electrons are the majority charge carrier, in P region, where electrons are the minority charge carrier. So means that here the concentration gradient of electron is more in N region when compared with the P region. Means that this is not in the proper distribution of the charge carriers inside the P region as well as N region. So what these majority and minority charge carriers will do, it want to move from its own region to the another region to make this PN junction as a equally distributed region. So that's why here the majority charge carrier holes are moving from its own region to the P region. In a way, the electrons will be distributed equally in P region as well as N region. So the holes available here in the P region wants to move from its own region to the N region where the concentration of holes are less. So that's why the holes also want to equally distributed from one region to another region. So the way the charge carriers are diffusing from one place to another place, due to that movement of charge carriers the current is producing. So we used to call that current as a diffusion current. Clear about the thing? What is this diffusion current? Okay. So once this diffusion current is happening, automatically this region will be arrived, right? Okay. So again, I will take this block. You already know the junction. So junction is nothing, it is a meeting place of P region as well as N region. Okay. So in P region, where holes are the majority charge carrier and electrons are the minority charge carrier. In N region, where electrons are the majority charge carrier and holes are the minority charge carrier. Okay, right? Okay. So now it want to equally distributed. All the holes and electrons should be equally distributed. Okay. So that's why what is happening? The holes available here in the P region. So I am writing here the holes available in the P region wants to move to the N region. Here what is available? Electrons are available. See, this holes while moving from P region to N region as well as the electrons moving from N region to P region, these two tries to recombine because both are the opposite charged particles. So this is a positive charged particle and this is a negatively charged particle. So what will happen? The holes try to recombine with the electrons, as well as the electrons also try to recombine with the holes. Okay, see, holes which actually loses the positive charge, okay, because the holes which is trying to get combined with the electrons, so means that this holes losing its positively charged. So once it losing its positive charge, we used to call it as a ion. That ion we would call it as a negative ion, because holes, the majority charge carriers are positive charge. Due to the recombination, the positive charge is losing. So once the positive charge is losing, here what is happening? The negative ion is producing, right? The same, come to this part, okay? Try to understand this concept also. See, electrons where it is a negatively charged particle, okay? So the negative is more. So while recombining, this negative is losing, right? Once the negative is losing, it will become the ion. But negative is losing. So what kind of ion it will be? Positive ion. So what is happening? Positive ion. So for one hole get recombined with the electron, negative ion is producing near the junction. Once the electron tries to get combined with the hole, automatically one positive ion is producing near the junction, right? So here negative ions will be accumulated in the P region and the positive ions will be accumulated in the N region, right? See, these are the ions. The characteristics of these ions is immobile ions. So these ions are immobile, means that it tries to accumulate near the junction, means that it is depleted charges. So what we call this? We called this as a depleted charge. Depleted charge carrier. That's why this region is termed as a depletion region. These charge carriers are immobile ion. So these charge carriers are getting accumulated near the junction. So that's why this region is termed as a depletion region. This is space which is having a charge. That's why we used to call it as a space charge region. Clear about the thing? What is a depletion region and space charge region? Next, come to the next concept. What is your next concept? Barrier potential. See, remember, in P region, which are the majority charge carrier? Holes are the majority charge carrier, right? Okay. Where these holes have to move? These holes have to move to the N region, because this Pn should be equally distributed. See, once this holes is trying to move from its own region to the N region, right? But near the junction, what are the particles available? Immobile ions are available. What kind of immobile ion it is? Positive ion. So the approaching is a positive charge. Available is also a positive charge. Again the same concept. So like or repelling each other. So the achieving is positive holes. Available there near the junction is also a positive ion. So what will happen? Like will be repelled. So this holes can't able to move after some particular time period. What is that particular time period? Once the immobile ions are accumulating near the depletion region. So after some time, once the immobile ions are getting depleted near the junction, the holes can't able to move from its own region to N region because of the positive ion accumulating near the junction. The electrons can't able to shift from its N region towards P region because it can able to reach till the junction, but after the junction it can't able to cross. The reason is near the junction the negative ions are getting accumulated. Approaching is a negatively charged particle which is available near the junction is also a negative ion. So both are the same particles, same charge particles. So it can't able to, this electron can't able to enter into the holes. So means that this will be stayed there in the N region. The holes also will be stayed there in the P region. So these will act as a barrier. This acts as a barrier, right? So even it is a barrier, see here, negative ion is here as well as positive ion is here. In a way, some potential or some voltage will be produced near the junction. So that's why this potential is termed as a barrier potential and this region is a barrier region. Okay. These and all happening in the PN junction diode once it is getting fabricated itself. So means that without the application of any electric field, right? I am not at all applying any electric field. I am just fabricating, otherwise making my P junction combined with the N junction. So once a P-type semiconductor combined with the N-type semiconductor, first the diffusion current will be produced because these P and N region should have the equal number of holes and electrons in both the P region as well as N region, right? So once that happened, automatically what will happen? The depletion region will be happen. Okay, so the depletion region will be happening. Once the depletion region happened, automatically it acts as a barrier. That barrier used to produce some potential which is termed as a barrier potential. Okay, right. So already I said drift current. So what is a drift current? It is a movement of minority charge carrier. Okay, right. So come to this part. Here for this N region, which are the minority charge carrier? Holes are the minority charge carrier. For the P region, which are the minority charge carriers? Electrons are the minority charge carriers, right? So what will happening? These ions trying to move from the barrier region to the next region, as well as this trying to move from this region to that region, right? So which is actually moving? Minority charge carriers are moving from N region towards the P region and from P region to N region. So due to that, drift current is getting producing, right? So these and all happened in the diode while we are not making any connectivity to this particular diode. Okay, right. Okay, so here I want to introduce you a particular word. So that particular word, which is a bias. So this is the word I want to introduce you. The word is a bias. So bias is nothing, it is an application of electric field. Otherwise, apply the electric field. So apply the electric field which is termed as a bias. Okay. So till now we studied 4 different processes, right? 4 different things: drift current, diffusion current, depletion region, as well as the barrier potential. Everything is happening under no bias condition, because what I did, I have taken one P-type semiconductor, I have taken one N-type semiconductor, that's it. So during this period itself, diffusion current produced, drift current produced, depletion region produced, as well as barrier potential also, right? So these and all happening while no bias. So means that I am not at all applying any voltage to my PN junction. Okay, but I can able to apply voltages also, right? So if I am applying voltages, at that time I used to call that as a forward bias, and I can call that as a reverse bias, right? So now you studied unbiased condition of no bias or unbiased condition of PN junction diode. Okay, if suppose this PN junction diode getting connected with the electric field, what will happen? Okay, so based on that, it is classified into 2 types: as a forward bias and reverse bias. Okay, already you know. So battery which is having a positive terminal and one more is having a negative terminal. So consider this is a battery. I am writing it as a BB. Okay, right. If the p-type semiconductor which is getting connected with the positive terminal of the battery and the n-type semiconductor which is getting connected with the negative terminal of the battery, we used to call it as a forward bias. P-type is getting connected to positive terminal and n-type is getting connected to negative terminal. Okay, that is the forward bias. Okay, next we will see the reverse bias. So what may be reverse bias? Okay, so this is a p-type semiconductor which is getting connected with the negative terminal of the battery, n-type semiconductor which is getting connected with the positive terminal of the battery, we used to call it as a reverse bias. Okay, so we can able to connect it either in the forward bias, otherwise we can able to connect it in the reverse bias also, right? Okay, right. So already I have drawn the symbol for the diode, right? Already I have drawn the diode symbol. So how the diode symbol is? Diode symbol was like this. Okay, already I told this is a anode region and this is a cathode region. So anode region means it is a plus, cathode region means it is a minus. Okay, recollect. Okay, so how you fabricated the diode? By using a fabrication of, otherwise addition of, combination of P region as well as N region. See, this is your P region and this is your N region. So this line is nothing which is your depletion region. So where the depletion region is created? Depletion region is created near the junction. So what is available here? What is losing here? Holes are losing. So that's why negative ions are produced here. So what is losing here? Electrons are losing. That's why positive ions are available here. Okay, so this region which is the depletion region should be represented by the line like that. Okay, right. Okay, see, then one more point I said. So what is that one? Forward bias as well as reverse bias. I will connect this in the forward bias. So this is a P region, otherwise positive, should be connected to positive terminal of the battery. N region should be connected to the negative terminal of the battery, which is your forward bias. So what is a reverse bias? P region should be connected with the negative terminal of the battery and N region should be connected with the positive terminal of the battery. So this is your reverse bias. By the forthcoming class, we will see how this forward bias as well as reverse bias is working. Okay, right. And for your laboratory representation, I want to tell you this. Okay, your diode will be generally black in color. Okay, you may have two metal leads. One side will be with the white color. So some side it will be white in color. So that side generally we used to represent as a cathode. Another one side we used to represent it as a anode. Okay. So while doing a laboratory, just to take your diode, it will be completely black in color. The white side represents the cathode and the opposite side represents the anode. Okay. So till this, study everything. By next class, I will tell you how the diode working in the forward bias condition as well as reverse bias condition, and we will see what are the other characteristics of the diode. Thank you so much.